Hey guys, and welcome back to a new video. In this video, I will show you how you can de-spaghettify your source code for your Android apps. Because I know legacy code is a thing, I know bad architectures are a thing, and I also know how development in the real world often works like, especially if you have product owners, if you have clients who constantly push you to developing new features, and you feel like you don't really have any more time to work on the code quality itself. And that often does not cause an immediate problem, but at some point you will realize the code I'm working on is an absolute mess. It's just full of spaghetti code. Everything somehow depends on each other. If there is a bug, then this bug somehow impacts the entire system, the entire app, because just everything is coupled to each other. So if you have code with really bad architectural practices, with anti-patterns being applied, I will show you a step-by-step guide on how you can improve that code architecture so it's really flexible and scalable again. Because in the end, a high code quality just has positive aspects. It does allow the team to just develop faster on the app because it's easier to add more features, it's easier to test certain parts, therefore the overall quality of the code base will also grow because bugs will be detected faster. And a nice side effect of a great architecture and a great code style overall is also that developers working on this code are much less likely to actually write bad code in a good code base. So if we would be in front of a super polluted river full of garbage, then we would also be less hesitant throwing our plastic bottle into that already polluted river than throwing this plastic bottle into a very clean mountain lake, for example. Even though the environmental impact is probably very similar. Just in the first case, we would think, okay, it's already full of garbage. This single bottle doesn't make a difference anymore. And that's the same type of thinking developers often have if they're working on a bad code base, that they don't even need to care about code quality because the whole code base is written with a very bad quality. On the other hand, if you're working on a very nicely written code base, you'll probably think twice whether to introduce certain duplicate code just to achieve something a little bit faster. So what's step number one when you have such a code base and you now finally want to improve? Step number one is always to understand what you're working on. So I've prepared a little sample code base here with certain architectural practices being applied that definitely don't contribute to a scalable code base, to a code base that we can easily work with, but specifically practices that I often see in existing projects out there. So step number one, understand what we're working with. Here we have an auth fragment. This is in the end just a simple, you can see 7-file structure with 2 screens. On the one hand, we have an authentication screen, still with fragments. We're using view binding here to access our views. We have a view model, which I will get to in a moment, some sort of Firebase analytics object. And here, when the views are created, we have a certain sign-in button to sign in anonymously here via our view model. And we observe the auth success boolean. And if that was successful, so if we logged in successfully, then we log this here in our Firebase analytics object and we navigate to the next screen. Let's take a look in the auth view model, how things look like over there. We have a little auth view model, Firebase auth object injected. We have our auth success boolean, or live data in this case, that we're working with. And we have the sign in anonymously function here, where we then simply listen, okay, when that was successful, we just update our state and that will notify our UI. And down here, we really just have a view model factory in order to instantiate such an auth view model with a constructor, specifically this Firebase auth object. Something you've maybe noticed is, here in this auth fragment, it actually inherits from a base fragment. Now my question before we dive into the code of this base fragment, what is the responsibility of this particular base fragment here in this particular code base? Can you tell me that? If you can't, then that is a very strong indication towards a violation of the single responsibility principle. Because if this base fragment would have a single responsibility, then you could communicate that clearly via the name of the class. But the vast majority of cases where I see people implementing base classes, that's really just about sharing some kind of data between all these child classes, between all fragments here, for example, about adding some functionality to a very specific functions like activity lifecycle functions, fragment lifecycle functions, defining some kind of template for a view model state management approach or so, and all that sucks. I haven't yet come over a use case of base classes in Android where I say that really makes sense to have to add inheritance here. The problem with base classes, on the one hand, if you call it base class as well, is, as I said, violation of single responsibility principle, because the name does not tell us at all what's inside the class. And it creates a super strong coupling to the entire code base, or at least to every single type of fragment in this case. If we have 100 fragments in this code base, then 100 fragments will be inheriting from the base fragment. One single change in the base fragment will cause 100 possible changes in the child fragments. That is really a form of hidden coupling where you don't immediately see that this class is coupled to all the code from the base fragment, because this is really the only place where you see this base fragment appear here. But changes in this base fragment can cause huge changes in all of its child classes, which is why inheritance is so dangerous. Sometimes there is valid use for inheritance, but in most cases where I've seen people create such base classes, no. So let's take a look in the base fragment to see what's in there. You can see it's a rather small class, an abstract class, so we can instantiate it itself. Here we also have a reference to the Firebase Analytics singleton. We have some kind of a helper function to create a toast easily in a fragment. I don't know if we do this here. No, I think we do this in the other fragment. But with this helper function, we could just show a toast with a little convenience function here in all of our fragments. And then we override on resume, so we just send a Firebase Analytics event that the user opened the app. Okay, let's take a look in the second screen, the second fragment, which is a location fragment. That is where the user gets after having logged in successfully. You can see also inherits from base fragment, also has view binding, also has a view model. And here we first of all request location permission. That's probably also no surprise to you. If we do have location permission, then we start the location update. So we probably or somehow observe the user's location and then do something with that. And here again, once the screen is actually shown, we check if we have location. If not, then we simply show a toast with our little convenience function coming from the base fragment. Do this every now and then in onResume. And here we again have a function that simply checks and requests the location permission in case we don't yet have that. Taking a look in the location view model, you can see a little bit more is happening here. So this location view model takes in our application context in order to initialize a fused location provider client, which is used in Android to observe location updates of the user. We're using a Firebase database, so we somehow save location values here in our Firebase database. It's really no real app. This is just some sample functionality that I thought of in order to showcase what I want to showcase in this video. We're using a location callback, which triggers with every single tracked location. So we get the new location, we read its latitude and longitude values, and then we reference our Firebase database, specifically the locations child, and we set a new value there via this map off. So we save the location and the current timestamp. Here in start location updates, we simply also send a Firebase Analytics log event that we now started location tracking. We say, okay, we have our location request. Every 5 seconds, we actually want to request this location update. And lastly, we have a location view model factory. So as you can see, it's a rather simple code base and definitely not as complex as your code base likely is, since we only have a very limited time here with this video. But I intentionally included very common mistakes here in this code base and will now show you how you can fix these mistakes if you also spot the same ones in your code base. Okay, so once you actually understood your code, once you maybe read through certain documentation, if you have that in an ideal case to understand what functions do, if not, then I would really maybe run the app, attach a debugger to it to understand the function flow, so which function calls which functions, which classes actually depend on each other. That is something you need to understand in the first place. If you have that and you now want to start fixing these issues in your code base and despaghettifying it. Step number 2 is, I would say, optional, but desired, but it's also a more advanced one, and that is to write test cases for your existing code. It's not always easy to write test cases for such existing spaghetti code, but if you can write tests that just verify behavior. So on the example of this app, for example, that locations are being tracked in the right interval after the right trigger. So once we accepted permissions, for example, then this piece of behavior, so what kind of problem your code is about to solve, this is independent of your actual source code, because also after refactoring your code, the behavior should stay the same. You still want to do the same thing. Once you did that, next step is to identify the duplicate code. So I think, at least if you have been developing for a little while, then you know that duplicate code is usually not something desirable. So first of all, take a look in your source code, take a look in a little isolated part of your project, maybe one feature, and take a look at what kind of duplicate code exists there. And now there are multiple different types of duplicate code or locations where duplicate code could occur. If you have duplicate code that is just duplicated in a single class and is not needed outside of that class, well, then it's super easy to get rid of that duplicate code by just creating a function for it. So imagine we would have this code here to take some location and store it in Firebase. We would have this twice here in this location view model. Well, then it would be pretty easy to just take this, put it in a new function in this view model, and then call this function at both these places. Now, if you have such duplicate code that does not appear twice in a single file in a single class, but in multiple classes, then it can make more sense to actually remove that duplicate code by introducing another class, or at least some form of utility class that provides this shared function. So this could be a Kotlin extension function, this could be just a normal high-level function in Kotlin, or a function of a new class you introduce, and then you make sure to add this new class to both the classes that have this duplicate code. And last but not least, if you have duplicate code in multiple modules, so greater modules, where the code is really duplicated at very isolated places, then my answer to how to get rid of that is not super straightforward. Then it really depends on a case-by-case basis how much sense it makes to get rid of that, because it's a bit more difficult with modules. But in the end, what you would need to do in that case is to add a third module that is shared between these two modules, which both of these modules can then access, and the shared module contains the code that was previously duplicated and is now shared between the modules. But adding another greater module is always something quite heavy to do for your code base. So here it really depends on what kind of duplicate code that is. If it's just a single line that is shared, I would probably not bother and I would not create a separate module. If it's a very crucial class that you need multiple times in your project, then that is definitely worth considering. These types of decisions about such architecture and module strategies, I go in a lot of detail in my Essentials bundle. I will put a link to that down below. Once you did that, so once you fixed your duplicate code of a specific feature, the next step is to identify coupling. And that's also where we will really start changing something about this code base. So we'll really make changes to this to have a much nicer architecture afterwards. But identifying which classes are coupled to which classes, that is really the biggest thing when it comes to refactoring. What does that mean if a class is coupled to another class? Well, if we have one class, location view model, and it makes use of another class, for example, this fused location provider client, or this Firebase database, or this Firebase analytics object, then that means this location view model is coupled to these classes. So it somehow depends on them. And every form of coupling also comes with a problem that if there is a problem in one of these classes, one class is coupled to, then this problem can not only be in the class where the problem lies, but also in classes that use this other class. So for example, if we had our own kind of location client here, or this location client has a bug, then that bug obviously not only impacts this location client itself, but all other classes that use this location client, because they might refer to functionality that adds this bug. So that is why we really need to identify this coupling and then remove it to really isolate certain components so that they do a single thing, that they have a single responsibility. And especially if it comes to such very data-heavy things, then these don't belong in view models on Android. So with data-heavy things, I mean anything that talks to APIs in the end outside of the device, outside of the Android app at least. So location tracking is something that definitely does not happen in your app directly. No, that is actually some kind of system service that comes from the operating system, where it definitely does not run in the process of your app. So there needs to be an API for you to say, hey, Android OS, please, I want the location updates, deliver this data to me. So your app is communicating with another app, another process via an API, via an interface, which in this case is this fused location provider client. Similarly, data-heavy things are, of course, databases like Firebase database, things where we send data over the network, Firebase Analytics, so actually both these send data over the network, but also a local room database, for example, would not belong directly in a view model reference, because this creates a super strong coupling between your room database and every single view model, at least every single view model that uses it. And this also causes the problem that if you at some point want to change a certain library, a certain approach, for example, you say, you know what, Firebase got too expensive, or Firebase Analytics got too expensive for this use case, I'm actually migrating to another library. Very valid thing to happen. If that happens, and you're using Firebase Analytics like this across your code base, then that change to another analytics logging framework requires changes across the code base. However, on the other hand, if we would make use of smart abstractions in our code, of smart interfaces, then we would actually only require a change in a single file. So that really makes sure spot these data-related dependencies, classes, and then isolate these step by step. So take a look at one single dependency first, for example, this Firebase Analytics object, and let's start isolating that. How does that work? First of all, in this architecture, I would add some sort of layering here, at least having a presentation layer for UI-related classes and a data layer for data-related classes. So we have a presentation layer, and by the way, in a real project, I would not have these as root packages, but rather have single feature packages separated by presentation and data, or optionally domain as well. So here, for example, the auth feature, I would call it auth presentation like this. Then we take all auth presentation related classes, we drag them in there, say okay, and we do the same thing for our location feature, for example. So location, have a presentation package in there and a data package. We drag in our location fragment view model. These are both presentation related. Click OK. And now we want to start writing a little abstraction for our Firebase Analytics object, since that is really what isolates this component and allows us to easily swap it out later. So the first step is always thinking about what is the common functionality. If you would now think of two separate analytics logging frameworks, what kind of functionality would you need from both of these? That is what declares how your abstraction would need to look like. We can create something like an analytics logger, make it an interface, and well, here in this case, we really just care about sending logs to the analytics framework. So this would be a function to log an event. An event is simply a string, and we can optionally pass some params if we want to attach certain data to this. So for example, just in the form of a map where we say, hey, we identify a specific parameter by its key, and the value could be anything. In this way, we really created an abstraction that is completely isolated of any specific implementation details. For example, that we say we must use Firebase. This has nothing to do with Firebase. There are no Firebase imports. But the concrete implementation we now create of this analytics logger interface, we can call Firebase Analytics Logger. And this could be a class. So we say this implements our analytics logger. We hit Command I to implement its functions. And now here in this class, we provide the explicit implementation details, how logging an event would look like with Firebase. So we would actually reference our Firebase Analytics object here. So Firebase .analytics, and we then make use of this object in order to log an event to Firebase. We pass in our event, and then here in these in this code block, we can then actually pass some parameters. So we can say we use our params, we loop over it with for each like this, we get the key and the value of each parameter, and then we say we attach that with this param function. So this is really just how this would look like with Firebase. If you now have a different analytics logging framework, well, then this implementation detail here, that would of course look a little bit differently depending on how that other framework handles analytics. But in the end, what all these have in common is that you want to send some sort of event that identifies what actually happens, which event you want to track, and optionally be able to pass parameters. That's something you would need to do for any analytics logging framework. And if we now do it like this, by the way, we could make this an object here since we don't have a constructor, so we effectively have a singleton by design. We could think about injecting this Firebase Analytics object, but this is already a singleton by itself in Firebase, so we could also use this as a member variable here. So now we have an analytics logger interface. We have the specific implementation, and now a very crucial architectural rule is to only depend on abstractions and not on concretions. That means we want to depend on this interface, not on our concrete implementation. So here in our view model, where we now make direct use of this analytics logger, that's something we don't want anymore. We don't want to couple our location view model directly to this Firebase Analytics logger, but rather remove this and provide an instance here of our just created logger, let's call it analytics logger, in the viewModels constructor. And you can see this now means we depend on the abstraction. This analytics logger is of type analytics logger and not of type Firebase analytics logger, because in that case, we could only pass a Firebase analytics logger. But if we do it like this, we are super flexible in saying, okay, for this view model, I want to pass this logger. For this one, I want to pass this one. And this now also deals with the issue that I've talked about before, because if at this point we say, okay, let's ditch Firebase, let's go to something else, let's use a different approach to analytics logging, maybe our own servers, then the only thing you would need to do is you would need to go ahead, create a new implementation of this interface, and then make sure that every single object receives this new instance. But since we depend on the abstraction, we can pass any form of analytics logger here to the constructors. So it's really just changing a single file, and the entire code base uses that new approach that is super flexible. And on the other hand, we also isolate this functionality here in its own class, so we don't violate the single responsibility principle. So now we of course need to use this logger as well. So we take this, and here where we previously sent this to Firebase directly, we can say analytics logger.log event. And here we can actually ditch this and make this a default parameter, so we don't have any specific parameters in our case to send to Firebase. So now we can do the same thing here. We can also log an analytics event. Under the hood, it will do this via Firebase in our case. But if the analytics logger gets passed in a different type of logging framework, logging SDK, well, then it gets sent to this one without requiring changes in this location view model. And that's really the core idea of every single isolation change that we will make here. And that's why it's so important to understand that. That's why I go into that much detail here. But that's the same approach we'll now also take on the one hand for the Firebase database and for our location tracking logic. So if we scroll down a little bit, we also get an error here now for the location view model factory. Since we need to provide this here, we will leave this unchanged for now because I will set up proper dependency injection here. You will see in a moment how that makes things even easier. Let's next actually create a data source. So we say, let's actually create a package for our analytics here and move these new in this. And then we say, okay, apart from analytics, we also have a data source, or we call it location, for example. And in this location package, we have a location data source. Make that again an interface. And now we define which functionality we actually need from a location data source. Data source is always something that provides raw data. And in our case, the underlying implementation will use Firebase in order to store that raw data. So the simple example, this is simply a suspend function that we need here to insert a new location. So save that in Firebase. We could also use a real local database for the real implementation, because in the end, if we are able to insert a location like this, then that's all we need to know about this location data source. We don't care about how that really works under the hood, at least in the classes where we make use of this instance. But we just need to care about, hey, we need to be able to insert a location from anywhere. So if we now go in here, we again create a Firebase location data source, make this an object again for the same reason, location data source. And here we can then hit Command I to implement this, how this now works with Firebase. In this case, we say, well, Firebase database is equal to, what is that? Firebase database dot reference. That is the root database reference of real-time database. Well, and in here, we can then just take the code we had here that inserts a specific location. So we'll just this part of the code, copy this, paste this in here. We reference our locations path. And we say here, we reference the location latitude we've passed, as well as the location's longitude. So now we can take this location data source interface and pass a value here to the ViewModels constructor again. So private val, that needs to be comma, oops. Private val, location data source, like this. And then we can use this location data source here in this file, in this view model, in order to insert locations. But we again depend on the abstraction. And if we now decide, I don't want to use real-time database anymore, but maybe my own backend, then we would just need to go ahead and say, okay, we did this specific implementation. And for the other one that we introduce, insert location will maybe make a normal API call to your own service that will then store it in a remote database. That, of course, works. But this view model won't require any changes. So here, instead of having this logic, having this view model be coupled to Firebase specifically, we want to ditch this. And we say, we instead depend on our location data source abstraction. And we say, we want to insert a location. And the location is really just the last location that we got here. And then we even don't need this code anymore. This is a suspending function here. I think we should also call await here, by the way. So dot await. So it's really a suspending call if we make use of this suspending behavior. But in a view model, we can easily say view model scope.launch, and we include this code in there, and everything will work just fine. And you can see our Firebase database is now grayed out. So another class where we could remove a reference and therefore remove one piece of coupling. Of course, if you needed this functionality in multiple classes to insert locations into this Firebase location data source, then you also need to inject this class here in the constructors of multiple view models, in this case, for example, or multiple other classes, in order to easily access that. And what injecting means, how that works, I will show you in a moment. The last change that we want to make for this location view model is to now also not make it depend on this fused location provider client. To be fair, here it's rather unusual or not so likely that this will actually change, that you will stick to a different approach of location tracking because this comes from Android itself. But still, this is logic you very likely need across the project, at least in a big project, that there's not a single place where you just need access to the current location, for example. So we also want to abstract that because it's definitely not the responsibility of a view model to track location and implement the implementation details for how that works. And whenever you have a callback like this, which triggers multiple times, you can see we can receive multiple location updates over a period of time, then I am a big fan of abstracting that as a callback flow. So if we now go to our location package, because location tracking is also location related, obviously, and we create something like a location observer abstraction, that's something that describes what this is for, and we then have a function to observe the location with the inputs that we need there, for example, the interval. Let's keep this dynamic. This could then return a flow of type location. So a flow is a data structure, a reactive one, that gives us multiple locations over a period of time that we can then easily listen to and observe. So again, something that does not directly depend on the raw location tracking logic. Yes, technically we coupled this here to the Android framework by depending on the Android location class. If you would, for example, work with a domain layer in your project and you really want to strictly make it completely isolated of the Android SDK as well, then you would need to create a custom domain level class for this location data structure. But I consider this too much for this simple tutorial. So let's go in here and we create an Android location observer class. That's not a concrete implementation of that. So here, this would implement our location observer interface. We hit Command I to override this function. And here we can then return a callback flow. So that's used to, again, take a callback and convert its emissions to emissions in a flow. If that's new to you, check my coroutines and flows masterclass, link down below as well. And now in here, the logic that we place is actually pretty much the rest of what we have in the view model. So we need to start location updates. So location request is also something we don't necessarily need to define in the view model itself. We don't need to request the location updates in the view model. Here you can see we need to keep in mind that we need to remove these location updates again. All that is logic that actually belongs more to the responsibility of a location observer. So what we can do is we can take this callback, cut it out, move this here into our callback flow without the private modifier, then go back, take where we define the location request, also cut this out, put it after our callback, and lastly, we also take the code here in our location view model that removes the callback, because that could also be the responsibility of our location observer. So you can see there are a few unresolved references here, starting with the fused location client. That's of course something we would need to provide here. In order to create an instance of that, you can see we actually need the application context, which we've injected here in the view model. That's also something I would not recommend you to do, even though with the application context, memory leaks can't happen, which could happen with the activity context. But I would always keep my view models on Android context free, since that makes it very hard to write local unit tests for this view model, since it depends on the Android SDK. In order to write JVM local unit tests for a class, it should not depend on the Android SDK directly. So we simply copy this line here, and we get rid of the application in the constructor of the location view model, and go in our observer and instead pass the application here. Because here we are outside of a view model, here we are in a class that needs the application context anyways in order to listen to the location. So here we can't isolate that anymore, but the view model does not strictly need the application context in order to do its normal things like updating state. So in here, we could then say we pass our client initialization code. Then we do get a little error here because we miss a permission check. I would say we just suppress that here for this example, so we don't get any complaints via this lint. And now a cool trick with callback flows is that instead of having it like this, which would immediately remove those location callbacks again the moment we start listening to location, that is that we instead want to use await close. This await close block here which will wait for the flow to close. And if we move in such code in there, what this will do is the moment the flow is closed, so the moment the underlying viewModel scope is canceled, for example, or the moment we intentionally cancel the flow collection ourselves, in that moment, the location callbacks here are automatically being removed. What does that mean in the context of our viewModel? Well, it means if we collect this flow in viewModel scope, which is the typical way to do it inside of a viewModel, then the moment the viewModel scope is cleared, the flow will also automatically clean up its callback, and therefore we don't need to manually think of that again to remove these callbacks in the viewModel. So when the viewModel is cleared from the backstack, the user navigates away, the flow collection automatically stops as long as you're using viewModel scope for the collection. And now the last issue here in this class is that we don't have viewModel scope on the one hand, and on the other hand, we don't have the location data source. So some of you might now think, let's take the new location data source and pass it here. So we could, of course, say we have the location data source, and then whenever we receive a location, we track it. Don't do that. Why is this not a good approach? Well, even though we now depend on the abstraction, and this is now isolated of Firebase, we now still couple this Android location observer to an implementation detail in some sense, or to an application detail, specifically to the fact that locations are being saved in a database, because that might not always be the case, right? Since if we take this insert location function call and we put it here directly in this callback flow, then there is no way for us to use or to work with this location observer without saving these locations. But if at another point we maybe just want to listen to location updates and display it on the UI without saving these in our Firebase database, then there would be no way to do that if we would include this code in here. So that's again not the responsibility of an Android location observer. Instead, at the place where we use this location observer in our location view model, that would have the responsibility to track these locations in a very specific context, in a very specific use case, on that location screen, for example. So that is why we want to ditch this here and instead just call try send and pass in our last location. Because try send will simply take this new location, send it into this callback flow, and then it's completely up to the class that uses this observer here what it wants to do with this location, which is much, much more flexible. So another class we have abstracted and isolated here. We have a very clear use case of this Android location observer. It doesn't do anything else than tracking locations. This Firebase location data source doesn't do anything than putting location-related data to Firebase or retrieving data from there as well. And we have this Firebase analytics logger, which doesn't do anything else than sending analytics events to Firebase. Now, the responsibilities of view models on Android are now to wire such multiple abstractions, such multiple dependencies together to make up a working screen that you're building this view model for. So here, to just combine these to make sense on that specific location screen, so that locations are frequently tracked on that screen and then being sent to Firebase and also being logged to Firebase. So a way how we could implement that is with a separate private val is tracking location, which is a state flow. And initially we're not tracking that. Then we can get rid of the uncleared function, by the way. And what we want to expose is maybe a location state. So the current location, just an example here. You could also transform this in any other way. But what we want to do is we want to say this depends on whether we want to track location. And then we say flap map latest. I will say something about what that means in a moment. We say is tracking. And if we are tracking, then we actually need to pass our observer, location observer, like this, the abstraction again, not the Android one. If we are tracking, we map this to location observer, that observe location with maybe an interval of every 5 seconds, and otherwise to an empty flow. Why do we do this? So what does this mean? Well, we're pretty much just building a reactive data structure here, a reactive stream. So whenever is tracking location changes, this flow that comes afterwards will trigger. Flap latest will take this most up-to-date value of is tracking of this state flow here. And depending on what that value is, it will map it to another flow. So if we are tracking, we want to map all subsequent emissions to the emissions that we get from our location observer, which are, after all, the tracked locations that we will now receive here, but only if we want to track. And before that, once we start tracking, we could then also take our analytics event and we say, okay, we're now tracking. Afterwards, we could say on each, so on every single location that we receive, we call our location data source and we simply insert it, because that's now a super valid place to do that. Since here in the view model, we just define how tracking locations works in the specific context of this location screen. and not in the context of the entire app anymore. That is what we did here. If we would place the database code in this Android location observer, which might be shared across the app, in that case, every single location tracking update would save the location in Firebase, even if you don't want that. And that will also, again, be very dangerous, since some people might then say, okay, I don't want this anymore. I don't want to track locations in Firebase anymore. So they would maybe comment out code here in this Android location observer. This would maybe break other parts of the project that still assume that the tracked locations are being saved in Firestore and Firebase. So you cause a lot of mess with such coupling. Instead, make sure to inject those single dependencies in your view models and then combine these here with the functionality that you want. And then afterwards, we could say state in, for example, to convert this whole thing to a stateflow again. We say, oops, view model scope, sharing started while subscribed. Really don't want to go into the flow details here. I'm doing that in a lot of detail in my coroutines and flows masterclass. But lastly, we need to come up with a default value, which I would say is just null here. So initially, we don't have a last location. But this is now, in the end, a stateflow of location. And with every single location update, we save it in our database and keep the latest value cached in our location stateflow. And once we then start the location updates here, we simply say is tracking location is true, which starts this whole thing here of this flow chain. And you can see suddenly we've reduced the amount of responsibilities of our view model from a lot, from actually 4, I think. So tracking analytics logs, from saving locations in database, from tracking locations, from possibly updating UI state, which is the main responsibility a view model should have on Android. We've reduced all those to just 1, to keeping the UI updated and serving as a bridge to the data layer. Also, since I will add dependency injection in a moment, get rid of this factory. We don't need this anymore. We will make use of Koin here as a dependency injection library in order to just define how these specific dependencies are being constructed just once. So what we can do is we can go to a root package, create a DI package for dependency injection, and we also need to add Koin dependencies, which I want to quickly do here. So we have Koin dependencies. I've created some cool live templates for that, which I'm super proud of. We have the Koin version, and there is no Koin plugin. So if we sync this and go to build.gradle, we can also add the Koin dependencies over here. Once that synced successfully, and once that's synced, we can start creating our little app module. So the whole idea of dependency injection is now to take our dependencies, so single instances of classes we want to pass around in our code, and inject these into certain classes. So we take an instance of our location observer, which we may need across the code base, and we just declare at a single point here in our app module. At a single point, we say, okay, we have a single off, which has a concrete implementation of our location observer. Okay, we delegate this to this class constructor, and then we bind the actual underlying interface we want to be able to inject. And that's now all we need for Koin to know, okay, whenever a constructor takes this location observer instance, use this instance instead, which Koin will create for us under the hood. Same thing for the Firebase stuff. Since these are objects, we need to use this single lambda approach, where we say, okay, we have a location data source that should use the Firebase location data source. We have a Firebase analytics logger. Same for the analytics logger here. We may need to provide our view models. So view model of location, view model. And I will really only make the changes here for this one screen. So there's also the auth screen for which we could write certain abstractions. But I think you really got the idea because the rest is very similar. I will still show you how we can get rid of the base fragment. But we now have this app module. We need to register this in our application class. So let's call it legacy app. Make this an application. And then on create, we say we start our Koin library. We register our Android context. So obviously, Koin needs to know the Android application context in order to use it to construct dependencies like this Android location observer. And then we say, you know what? I have a few modules, in this case, just one actually, which is the app module. Registering this application class here, name, legacy app, and that's all we did. That's how we can create dependencies with Koin and inject these automatically in view models. So here in our location fragment, we would need to just swap this function out with the view model function that comes from Koin. So just by view model. We don't have a factory anymore, so we can also swap all this out. What's the issue here? Seems like I am using the composable import for Koin. Okay, just quickly swap this out. Let's optimize this a bit. And can we import this by view model? This one here, like this, and then we don't have any more errors. So this is just the delegate from Koin that will instantiate this view model with the dependencies that we've provided in Koin. Something else we can optimize in this file here, in this location fragment is, you can see we have some duplicated code here and here. As I've told you before, if we have duplicate code in a single file, we could create a utility function in that single file, so just has permission or so. But that is a type of functionality we likely need across multiple places in a project that uses location access. So I would cut this out, go in here and create something like a context extension to say we have a context extension function, whether we have location permission or not. And then we already got rid of another piece of duplicate code here. We paste this in there, just say this is the context reference, and then we return whether we have both of these. So has course and has find location permission. So this is now a utility function, same behavior, which we could use here. So if we don't have location permission, we call this code much cleaner now, and up here as well. So if don't have required context, we don't have location permission, then we show the toast. Yeah, and the same thing we could do for the base fragment. So as I said, the most terrible thing to do with a base class within the parent class is to just introduce this to share data, to share functions. If you catch yourself introducing a base class just to share something like this, please don't do it. Instead, that can be easily fixed without inheritance by cutting it out and also making this a utility function that maybe extends the context, something like this. And then we put this in here, actually just the toast, and we say this, and then you will notice we can remove it here. In the location fragment, it will complain, but just because we need to say require context.toast. And there we go. We fixed that. We don't need the base fragment anymore for that. The only thing we can't easily replace like we did before is if we rely on overriding the same function for every single child class in order to maybe send an analytics event here. But even in that case, I would highly recommend you to get rid of the base class and rather add this functionality here in a separate class you inject in every single of your fragments. So instead, you would say something like open analytics delegate or so. We say we pass in our analytics logger, our abstraction again, and this will then really just keep a function to log app open, something like this, which would also deal with a case that you have more functionality here that you would include in this overrided statement. So we put this in there, use the analytics logger instead, remove the bundle since we're using the abstraction. Could also say private val. Then we need to make sure that Koin actually knows this, so we can inject this in our fragments. So here, app module, we say single, and we say location or app open. How did we call this? App open analytics delegate. We provide this just by this line. It will automatically create this class instance here. Where did we create this? In the base fragment we did, right? Yeah. So automatically create this, pass in our previously provided analytics logger. We can then get rid of the base fragment, luckily. And in our location fragment here, we just say we inherit from the normal fragment again. And instead, we say private val. How do we call this? Analytics delegate by inject. That is how we get a dependency from Koin. And we say app open analytics delegate. And now we can just use this here in the fragment itself in on resume and say analytics delegate log app open. Yes, that is one more line of code for every single fragment, but that is not an issue. You are much, much more flexible with this approach. You don't create this strong coupling as before, that one change directly impacts all kinds of fragments, unless, of course, every single fragment uses this analytics delegate. But you now at least also have the option to say, you don't use this functionality. If you really want to use inheritance in that case, then don't call it base fragment, but rather, if it's just for logging the app open, then call it something like that. Call it app open fragment or a log app open fragment, something like that. You get the idea, but call it based on something that communicates its purpose. And if it just has a single responsibility, then that is okay. I'm still not a big fan in that case of using inheritance. So I think you really got the idea. We could, of course, make more changes here of authentication. Here we also need to say we inherit from fragment. We need to make sure that we also call this an on resume here. But other than that, yeah, we are using Firebase auth, so that would be another thing to abstract out here. So we pass in our own authentication interface that we then call here from the view model. And from this point on, you have a really, really solid code base. So you have clear classes with clear responsibilities. Everything is well testable, because if you now want to test the location view model logic, for example, you get to decide which dependencies you pass here, because you could create certain fake dependencies in your test cases that are just optimized for testing. Typically, you don't want to make real calls to your real Firebase servers and drain your quota when you run your tests. So you instead want to pass something else here, which you're now absolutely free to do, but weren't before. Also, we've reduced the coupling by a lot by making use of smart abstractions. Every single piece of the code base of the functionality is now isolated. So if multiple classes need to observe locations, that works by just passing in this location observer in these multiple classes. All this does is it observes locations. It does not have any side effects that are not directly related to tracking locations. If multiple classes need to insert locations or get location data from Firebase, you would just need to pass this location data source, of course extended if you need more ways to interact with this data, to retrieve this data. But you get the idea. I really hope this helped you to take the first steps in improving your code base. As I said, start in a more or less isolated piece of code, which is very hard in a spaghetti code project. But take a look at one feature at least. Pick a single dependency where you think, okay, I could have a clear abstraction for that. Write the abstraction, write the concrete implementation, and then first take this dependency and swap it out in all occurrences of your code base where you use that previous concretion. So like the Firebase Analytics logger, we swap out with the interface instance and make the code work with that single change first and then jump to the next change. I know it was a longer video, but I think a quite important one because it's just completely normal that the legacy code is out there. The Android world is developing very, very fast. And with the requirements of typical client, typical companies, typical product owners even faster. And they typically just don't see an immediate reward of an improved code quality because they often have no idea of coding, let's be honest. And they don't see a new feature, they don't see a new shiny UI component in their app. So they think, okay, we can get rid of that. We don't need to care about code quality, which as developers, we can of course say is not correct, but it is how it is. So I hope you enjoyed this. Thanks so much for watching. Down below, you will find very, very advanced and detailed courses about architecture. So if you learned something here, then guess how much you learn, especially in this Essentials course, if you're looking for architectural progress. Check it out. And other than that, I will see you back in the next video. Have an amazing rest of your week. Bye-bye.